So hello everyone. So my name is Raghavendra Ramachandra. I am from Norwegian University of Science and Technology, Norway. So in this work, we are going to present a novel technique for fingervein verification. Fingervein verification. To this extent, we have introduced a novel CNN-based network using convolutional multi-head attention network. So outline of my presentation is as follows. So I start with a very quick introduction on the Fingervein biometrics, followed by the research contributions, and then the proposed method and the experimental results and conclusion. So Fingervein biometrics is quite popular from past decade. So because of the several characteristics that includes high accuracy, and it is difficult to spoof because the vein characteristics are not visible for the naked eye, and also the variation of the fingerprint biometric characteristics is less over the time, and it is more user convenient. That means that the interaction with respect to the sensor is more convenient for the user. So among the several other biometric modalities, the fingerprint is the one such modality where many people have started to use this in several applications, and most of these applications that we found is in the finance sector. So there are several ways how the finger vein can be captured. So the popular way is to use the normal LED based illumination. So when we try to capture the finger vein based on the LED based illumination, which is very cost effective in fact, so there are three ways how the light can be illuminated on the finger. So either we can illuminate the light on the sideways as shown in the left side of the figure here, or the light can be illuminated from the back side of the finger, and then the camera is placed at the bottom so that the light that can penetrate inside the finger can be imaged in the camera which is placed below. And in some cases the both side and back penetration light penetrations has been used. So the idea of this finger vein imaging is that whenever the blood that is flowing to the veins, that is especially the hemoglobin, that will absorb the near infrared light, and it appears dark compared to the neighborhood tissue region. So therefore, as we seen from the figures here, so we can see that the dark region clearly represent the vein structure. So it has been well shown from the previous studies that these vein structures are unique from finger to finger, and also unique from the subjects. So when we look into the existing literature on the finger vein verification, there exist several works, and these works can be classified into the non-deep learning based and the deep learning based methods. So non-deep learning based methods are very well adopted for the finger vein verification. So those things, for example, like using of maximum curvature points and so on and so forth. So these kind of techniques basically do the basic image processing so that they can extract the structure of the finger vein pattern. So however, those kind of techniques are very good as long as the quality image capture quality is good. But however, due to the variation in the light, and also due to the variation of the poses and other kind of challenges in the finger vein capture, so these non-deep learning based techniques are less robust for finger vein verification. So that has resulted in the several deep learning based techniques since 2015 until now. So most of these techniques, as it is summarized in the table here, are based on the pre-trained networks. So several techniques use the shallow CNN architecture with 3 convolution layer and two fully connected layer. So and then some of the proposed technique also use the pre-trained network as the backbone over which they evolved a new architecture that can perform the finger vein verification. The recent trends in the finger vein verification are mainly on using the residual attention blocks, and the attention blocks are used both for the channel and the spatial attention blocks, and also the use of CMS networks with the attention module as becoming more popular in the finger vein in the finger vein architecture. So in this work we come up with the new architecture, which is very lightweight architecture. Basically it uses only 3 convolution layer followed by an multi-head attention module, also in self attention module. So our goal is to see like how our proposed method can generalize on the different publicly available databases. The one of the main challenge with the finger vein verification is the availability of the large scale database. So almost all the work that have been reported until now are based on the very small database that has like 100 data subjects or less than 200 unique fingers, in which every finger has less than 10 or 5 images captured. So on such a small scale database, building up a deep neural network is obviously a quite challenging task. So therefore, to address several limitations in the state of the art, in this work we have threefold contribution. The first one is the new technique for finger vein verification. So for to which we try to introduce the multi-head attention network. So we name it as VeinAtnNet. And the second contribution of our work is to argument the small scale databases that are available in the literature. So to overcome one such limitation, we put up an effort to collect a new database with 300 unique identities that are captured from 75 different data subjects. That will result in 300 into 92. That means that, like, for every finger we have captured 92 different instances, that is covering from 2 days until 1 week, depending upon the availability of the data subjects. So in total we have like 27,600 vein images, and of course this database is publicly available. So we label this database as FV300 in this paper, and we are going to present our results on this database also. So in the last part is we perform the extensive experiments. So experiments on the newly proposed data set as well as the newly proposed technique. However, to further evaluate the robustness of the proposed technique, we try to evaluate the performance on the two publicly available datasets. While we evaluate the performance on the two publicly available datasets, so we try to use already the pre-trained network from our newly developed database, and then we fine tune our pre-trained network on the new databases to benchmark the performance with respect to the state of the art. So this is the representation of our proposed method. So proposed method is based on both the normal finger vein image, and we also use the enhanced finger vein image. So both of these images are in parallel pass through the proposed network, which has three set of convolution layers followed by the self attention block, and then the fully connected and softmax to obtain the scores. So these both from the normal finger vein image as well as the enhanced finger vein image, we obtain the scores, and these scores are combined using a simple sum rule to make the final verification score. So when we perform these experiments on three different data sets, and we also compare our proposed method with both deep learning and the non-deep learning techniques, as we see from the table here. So on the newly collected database, our proposed method has achieved a very good performance with less than 1% of equal error rate. So while with the other publicly available database, the proposed method still indicates one of the best performing performance compared to the existing state of the art techniques. When we look into the number of learnable parameters compared with the existing methods and the proposed method, we notice that the proposed method has achieved a very little number of parameters with 58.2k learnable parameters. That means that our proposed method is lightweight. At the same time, it is more accurate and more robust in classifying the finger vein images. So further, to understand the performance of the proposed method, we also try to do the interpretation of the results. So to this extent, we use the LIME as an explainability technique for our proposed method. So here we can see that if you give the normal images, the most of these regions that are selected is basically the texture as well as the vein based region. But however, when we give the enhanced image, it is interesting to note that the most of these regions selected by the proposed network is on the vein part. So with this, I would like to thank you for listening to my presentation. Please do visit our poster to have more extensive discussion on our proposed method. Thank you very much.